that use a diaphragm for moving a fluid. So when we have a powder, we can use what we call the fluidization. So a fluid, a dry fluid, generally a gas, is passed through a granular material called powder. And the result of those two could be a medium that can act as a fluid, can flow against gravity, can flow under gravity, can be pumped with fluid technology. Of course, not all powder can be fluidized. Some of the characteristics that the powder needs to have is low bulk density and to be dry and um, not have the characteristics to stick together. So if you have a powder that is used to the grains are sticking together, maybe it's not easy to fluidize. There are also some other particular characteristics that can change from powder to powder that make this powder more easy or less easy to fluidize. But for sure, the level of humidity and the low bulk density are two main important things that we need to consider. Arrow has a long story in powder pumps in general, with AOD at the beginning. AOD means air operated diaphragm pumps. As you can see here on the left, a typical air operated diaphragm powder pump is added with a fluidizing section. You see the arrow. Sorry, you can see the light blue arrows here. That means we introduce powder in the chambers and make the product fluidized. So why diaphragm technology in general is a good solution for pumping powder? Because it's self-prime, so it creates vacuum, make the powder flow into the chamber. It's very gentle, so there is no risk of shear or doing like separation effect from gas to powder. There are no mechanical seals and no sliding parts, so there is no parts where powder can remain stuck into the pump. When you go to electric solution, EVO, the idea is very similar. Just the only difference is that we want to fluidize the powder really at the beginning, at the entrance of the pump, because we don't have the internal fluidizing circuit. So I can show you here a small video to show how diaphragm pump work. So you can see here the diaphragm pump, the diaphragm is moving, and these small particles, if are fluidized, are flowing into the pump and going out exactly like a fluid. So now let's go to the next topic. Case study focus. The project that we faced where we provided the EVO solution and how EVO was a solution in this situation. So the customer is a carbon black producer. Carbon black is used for several reasons in different industries. It's known since decades as a filler for rubber, for plastics, also as a pigment for some particles, for some plastic part that need to be very dark or black. So, and in the nearer years, by the way, carbon black became also very high use as a filler in anodes and in cathodes in lithium batteries. So it's an exploding market. What was the application? Actually, carbon black is produced by burning some residuals of petrochemical industry. It goes through a reactor, it's burned, and actually the smoke that get out from this partial burn is cooled down and condensed, and it becomes the carbon black eventually. So it goes through different process section, which are named filters, to increase its purity and to move this product from one stage to the other in the production. Several ways are used, and our customer was using this way to fluidize powder, to fluidize carbon black and pump it out to the next process by using diaphragm pumps. So they were already using diaphragm pumps, but this was not anymore sustainable from economical and environmental point of view. Pump had to be fed by air or even nitrogen in some area because of ATEX application to make it inert. And so the consume of energy and also the potential environment pollution are quite high in this condition. So this customer for the new plant, for the plant expansion, they wanted to go electric. So the solution came with EVO. We knew the issue and we started presenting this product, the EVO pump. Consider EVO pump is a real process pump. So it's not just replicating a diaphragm pump, but it's also designed to be rugged and robust and be able to run under heavy duty process 24/7 with the minimum as possible downtime in terms of maintenance, especially, so in terms of need of maintenance and maintaining time. So thanks to these advantages, after a few months that those pumps have been tested by the customer discovered that first, they didn't need to, for the new plant expansion, they didn't need to change their process conception. They were able to keep their process conception by using this diaphragm pump, moving the powder from one stage to the other. So good standardization, but they were just changing the technology from normal diaphragm pump to electric diaphragm pump, saving a lot of money. Also better uptime, as we told. This pump is easier and has lower maintenance than a normal diaphragm pump, at least what the customer has tested. Reduced use of compressed air and nitrogen, reduced energy consumption, and reduced environmental impact. For all those reasons, at the end of the day, customer decided to buy this pump for its application. Which was the setup in this particular video, the average setup, because of course, depending on the stage of the process, working parameter could vary a bit. But the speed of the pump is more or less to the maximum speed, 180, 198 RPM. The pressure the pump developed, there is no need of pressure here. It's just enough to move the fluidized powder from one stage to the other. So it's running about 1.4, 1.6 bar gauge, which is 20-25 PSI. And the mass flow rate of the real powder, without considering the gas, the nitrogen that customer is able to pump, is on the range of 260 kilograms per hour, which is 570 liters per hour in US dimensions. As you can see here, how the pump has been fed. So there is a residual N2 going with the carbon black that coming from the beginning of the stage, or additional N2, so nitrogen, which is injected at the entrance of the pump to keep the fluidization. And those medium, which is fluidized carbon black, goes out to the next stage. And at every stage, there is a point at the top of the filter where they are able to separate the excess of nitrogen and maybe reuse it in other stages. Here are some pictures of the two pumps. Of course, you can see we're testing pumps. So the setup is a bit provisory. I mean, it's not a definitive setup, but you can see the first pump arrived and they've been installed in the outside area, so at low temperature application, and it happened more or less 1.5 years ago. And after 6 months of test, more or less, a customer decided to have a second test pump, and this time to start testing in high temperature area here, with high temperature powder, because as you have seen in the slide before, the temperature of powder can vary if they are at the very beginning of the process or at the end of the process, close to the packaging stage. And after a few months of of this pump running in parallel to the existing pumps, customer decided to select this pump for the next, officially select this pump for the next plant expansion. And the order was for 20 identical ATEX certified pump. So I can show you a video of this. You will see you'll hear a bit of noise. It's not mainly the noise of the pump, but it's more the noise of the air-operated diaphragm pump behind. There is just a small noise made by the EVO pump. All the rest is the air-operated diaphragm pump behind this pump. And you can see the pump is very stable, it's not moving, it's not vibrating, it's running at 180, 190 RPM. Other generic feature and benefit are using EVO pump for pumping powder. Of course, you can eliminate manual or semi-manual activity with risk of people get contaminated or even just fully dirty. So you get a more environmental friendly pump, less contamination, cleaner environment. You gain in energy and time efficiency. Since the pump is electric and has a VFD provided together with the pump, you can control the process in a more precise way. And if you need, not provided direct by Arrow, but some partners can do it, you can mount this pump on a portable solution. I mean, the pump is quite heavy anyhow. It's not a pump that you can move by hands, but if needed, can be on a very robust cart, can be considered a semi-portable. Let's say that's why I say semi-portable solution, because it's not fully portable like some other air-operated diaphragm pump, but at least it can be moved if necessary. And it's compact compared to other way to move powder like big screw system or big screw conveyors or vacuum conveyors, which are definitely much more, take much more space and also taking not portable. So which are other potential materials, application or markets that where we can use powder pumps? There are several powder, and actually we as Arrow are pump experts, not necessarily powder experts. So I can list here some of the powder that I've seen transferred by powder pumps, could be EVO or pneumatic, like fumed silica, light iron oxides. When I say light, that be very light. I mean, not all iron oxides are the same. There are some classifications, so we need to go for the very light one. Activated alumina, graphite, and carbon black, like what we have experienced in this case study you have seen. There are for sure many others, and if you are in the chemical processing, pharmaceutical, paint, or raw material extraction, you probably know better than me which are the powder that could be pumped by this type of, that could have those characteristics. Now, of course, any powder has different features. So some tests can be done, like see if you can fluidize the powder. It's the first test. Some others could be done by moving the powder, see it not sticking together, measure the bulk density in order to understand if this pump can be suitable for a powder pump or not. As I told you, this was a very short webinar. So we are almost through to the finish of the webinar. I leave this Q&A session. As my colleagues say, you can use the button here below. We are here for supporting you and answering your question. Here you can see the
Hello.
full. Yeah.
Hello, Thomas. We have one person that I will allow to talk. Mr. Vinod Sauji, please, you can talk.
Hello. Hello.
Hello, hi, we can hear you. Okay, I think we can proceed. He's having a few sound issues here.
But you can write down a question and.
Hello. Hello. Am I audible?
Yes,
Can you hear
yes.
me?
Yes.
Okay. No, our question is that whether can we convey the PTA powder, that is pure terephthalic acetate powder, which we convey normally, it's in the powder form, and we are currently using nitrogen to convey the compressed nitrogen gas to convey.
I mean, the
Hello.
sound is very bad. No, I cannot really hear you.
My question is, can we convey PTA powder through this through these pumps?
Which type of powder?
It is a polyester purified terephthalic acetate.
I mean,
powder, which is a raw material for us.
I mean, first I heard very bad but I can
Can you open the chat window? I'll write my question in the chat window. Can you enable the chat window or something like that? Okay, I'll ask a question.
I think it works better if we see the question through the chat there, because sometimes audio is not working perfectly. No, I don't see any. I don't see the question. So yeah, write the question in the chat in case we will send answer to all the questions. Oh, okay, I see now. Yeah. PTA powder. I mean, 40 tons per hour is a huge number. I mean, I will provide you the answer here on the chat, but the question is, can we convey PTA powder at 40 tons per hour? I mean, 40 tons per hour is a huge number. It's probably much higher than what one pump can do. Now, it depends if you can use more than one pump for this. But if you need really to move such amount of powder, probably powder pump is not the right system. But in terms of type of powder, if it's a very light powder, is a polymeric powder. I mean, I cannot guarantee, but there are some good chances that you can you can use the powder pump. Now, in terms of quantity, we are really out of our range.
Hi, Thomas. We have more questions here. One from Gabriele Tiglio. So is there any similar handle from customers to chase from this solution?
Handle. I mean, this from Gabriele Tiglio is not clear. Is there any similar handled from customer to chase for this solution?
And Thomas, he added, I mean, similar powder or on different markets.
I mean, we correct. Okay, now is clear. There is with EVO, we had tried not with this customer. We had some trials with other powders like fumed silica, but I would say that what is important is that what can be pumped generally, what can be pumped by an AOD powder pump can also be pumped by an EVO. It's just a matter of doing the right fluidization. So this is more or less the answer here. Of course, EVO pump is a young product, so we don't have tons of case studies on powder, but we know that since the technology, the pumping technology is exactly the same, whatever can be handled by powder pump can be handled by EVO. Is it suitable for print and paste? This is Shiv Kumar Singh asked. Print and paste is quite sticky as per what I know. Now I don't know all the materials, but print and paste is something quite sticky. So if you pump it as a fluid, it will work. It's not going to be a powder pump. It's going to be a normal pump. This could be suitable for print. But if it's like the powder printing medium, this is probably quite sticky to be used with powder pump. Yeah.
If I had written the bulk density the power per meter cube.
So I'm answering the question from Michael Peterson. The aero powder pump, the classic one, fluidization, does fluidization in the chambers. Yeah. So there is an issue on EVO pumps. Okay, first the EVO pump have a more continuous flow in the manifolds. So the EVO pumps have a more continuous flow in the manifolds, and so it doesn't have powder to steady in the manifold because it's more continuous, because it's three-chamber pumping. And having said that, the only thing that is suggested, and we have experience with our customer with carbon black, is to flush the pump only with fluidizing gas without powder for a few seconds before start adding powder, in order to avoid this effect of stacked product inside the pump. So from one batch to the other, for example, or after the batch, flush for a few seconds only with gas, so you can fully empty the pump. In the beginning, you can fully free up all the parts and then start with powder. I hope this answered the question. 850 kilograms cubic meter. This is, I think, again, regarding the PTA powder. 850 kilograms per cubic meter is within the possibilities of the powder pumps in general. Now, as I told, it's not the only information we need, but it's within the possibilities. What I'm still concerned is about the quantity. I mean, 40 tons per hour require a lot of pumps. Dave Phillips. I answer now the question from Dave Phillips. We currently use a vacuum conveying system to transfer 3-inch line. Okay, how easily can change this to this pump with our system? I mean, I need to know your process more in detail, but I think that 3-inch line within a filtered receiver, the rotary airlock valve. I mean, I cannot really answer to this. What I can say is that the system that uses the pumps is quite simple to put in place. I mean, you should have, of course, nitrogen or dry air to fill with the pump. So you need the compressor, but I think you have it. But I don't know how could be important for you to remove what you have as of today. But what I can tell you is that it seems to be a good application for our solution. That's for sure.
Hi, Thomas. We have Andrea Kokuni. So, Andrea, you may want, you are allowed to talk if you want.
Yes. Hi, Thomas. Hi, everybody. And
Andrea.
my question, I have a couple of questions for you. And first is the capacity. You said that the capacity you had with that kind of pump was 250 kilogram per hour.
Yeah.
And which was the density of the carbon black you conveyed?
The bulk density of the carbon black was quite low. I don't remember the exact number here, but was in the range of 0.5, 0.4 grams per cubic centimeter. Also, the particles were, if I don't remember, I cannot provide the exact value, but were quite thin, because also carbon black can have different type of particles, so particles were quite thin. Now it depends also on for example, I don't want to go too technical, but also depends on the ratio between surface and mass. Because if you have high ratio between surface and mass, it means that the
ratio between surface and what? Sorry.
Of every single grain of powder.
Yeah.
So if you have a high ratio and high surface compared to the volume, to the mass of the single grain of powder, it's easier to fluidize. So maybe you need less gas to move the same quantity of the same mass of powder. So you can move more powder. But again, it's really technical here. So generally, what you can do, I mean, I know you, Andrea, you are from one of our. So what you can do, you can estimate what you can do with a normal powder pump, and it shouldn't be that distant. It should be more efficient, I would say, with EVO, because we have 3 chambers, but
yes,
more or less in the same range of quantity.
Yes. I was expecting that the density was around 0.5, and you confirmed that.
Maybe a bit less, probably, but yeah, in this range, yeah.
And the other question is, do you have experience, as far as you can know, which is the maximum density of powder you can convey And if you have issues, there could be issues with the abrasive powders, like a quartz or something like that.
I mean, I separate the question into, so the maximum bulk density,
Yes.
we generally say that the real maximum is around 0.85. So more or less the quantity that the guy provided here. The best efficient in pumping powder we get at 0.6 gram per cubic cubic centimeter. But then also it really, as I told you, it really depends also on the surface ratio compared to the volume, surface to volume ratio. But so I would say that the two things are quite important, apart from humidity, was what I told before. In terms of abrasive, I don't see any problem with abrasive. Now, I don't think that we will be able to pump quartz because the bulk density of quartz powder should be quite high. But if it's just a question regarding abrasivity, I don't see. I mean, the diaphragm pump is quite good with abrasive fluid, so I don't see the problem with abrasive powder.
Okay. Yes, I see as far in my opinion, I see that the capacity is not so high and compared to mechanical conveyor. Of course, another question. Of course, maybe with this kind of pump, you can reach longer distance.
We can reach quite long distance. Yeah, we can reach quite long distance. Yeah. That's for sure. Yeah, because the help of the fluidization, the advantage of the fluidization help us to reach long distance. Like,
for example,
what I can tell is that I've seen. I don't know which is the distance with this carbon black. It's probably more than 50
well, generally speaking,
I've seen fumed silica to be pumped almost to 100 meter far away. It was a very light fumed silica, by the way.
Yeah, fumed silica is 0.1.
Yeah.
About. Okay. Okay, thank you very much.
You're welcome. I see Edna is answering to another question on the Q&A session.
I was typing another answer here from Justina, Thomas, and you can complement. What are arguments to convince the end users to buy an EVO solution? So isn't a UDD pump can be suitable for this application?
Yeah, the question is the reason why the offering, because the customer, as I told, the customer wanted to save energy and to be much more environmental friendly. And when they say save energy, for them is a big amount of energy, because they are not just using compressed air, but in some area they were using even nitrogen to feed the pump, to feed the air valve of the AOD. So you can imagine the cost of the compressed air plus the cost of producing nitrogen, and those nitrogen was simply blow out in the atmosphere at a certain point. So of course they want to be much more environmental friendly and less and decrease their cost.
All right, I think there is no other question.
No, I don't see any more questions.
So thank you again for attending the webinar today from EVO.
Hi, Clemence. We have just one person more that would like to talk. It's Jin Kozumplik. So Jin, please, if you can, please feel free to talk.
Go ahead.
Good morning, everyone. I have a lot of experience in the AOD powder pump applications. I do have a customer that has 8 AODs right now. And what I was curious about is that they're pumping a 3M 16K glass bubbles to make Jeep tops with. And you know, there is a humidity issue every once in a while. They've been able to you know, starve off, I guess, packing issues. I guess my question was with the EVO pump, is there any controls that measure humidity inside the chambers? And what are the fail safes if the pump does pack?
Yeah, good point. So there are a couple of things that we should say here. First, in terms of humidity control inside the air chamber, no, there is not. The only way to control the humidity inside the chamber is to inject dry air to the inlet manifold. So that's why the customer in this particular situation is injecting dry nitrogen. This is flashing with dry nitrogen a few seconds before starting with adding powder, and even a few seconds after they finished the transfer batch. So in order to keep the right humidity, but there is no way to control it inside the chamber. So this, I hope this answers your first question. The second question in terms of controlling the product pack, what we do here, we control the torque of the pump. This is a particular feature of EVO. The pump has a torque control system. So if we generally turn down the torque to a lower value from the 100% because we don't need high pressure when we move powder. And if there is a stack, there is torque control. So the motor simply stops if there is a stack of powder. And this could be a good, let's say, information that there is a stack of powder. And you get a torque alarm on the VFD. So it's exactly like we can do with EVO with fluid, where we can control the torque and avoid to have overpressure. In the same way, we can have this type of information when you're pumping powder. The only thing which is important is always to not run at the 100% of the torque, because we don't want to overcharge the system anyhow. So actually, in this application, the customer ran at 100% of torque for a while. Then I've been there and suggested them to reduce, but actually the test was going well even at 100% of torque. Simply they did not need it. They did not need it. And also it's much better for the system when in case the powder pack do not have the full torque on the powder. But apart from that, yeah, I mean, I think that this answers more or less your question.
Sure, I appreciate the you know, the response. So the customer would need to monitor humidity before the powder would go into the pump.
I think so. I mean, yeah, I think so. I'm not a process system expert. So, but as per what I know, I think this is the point here.
Sure, I think it'd be beneficial, you know, for, you know, someone to, you know, have a sensor mounted, you know, to measure humidity inside the pump and be able to adjust, you know, nitrogen and or, you know, dry air, you know, when needed, I guess, at that point. So, you know, that was my question, and I appreciate your time.
Thank you very much. So if there are no any more questions, I leave the stage to Clémence to wrap up and closure.
All right. So thank you again for attending the webinar today. from Aero. You can scan the QR code here to visit our website to learn more, complete our contact form to have someone contact you, or subscribe to our YouTube channel to rewatch this presentation. Have a nice day.
Okay.
Nice day. Thank you very much.
Bye.